first things first. I said right at the start, we're not living in a vacuum. We need to understand what's already going out there. So this is not a complete list, but this is an indicative sort of set of slides that give you a sense of what's going on in the router space, IoT security space. So first thing, IETF, manufacturer usage description. I don't know how many people are familiar with this. We do embrace the tenets of this quite thoroughly in terms of what we're doing with D3. The idea is quite simple, and I won't go into the minuet on the technical tip. The idea is each device knows what it is, and it knows what it is by issuing a link to a document that's held on a website. You download that document, you unpack it, and then the contents of that document, which is signed by the manufacturer, so there's a level of sort of attestation there. So the content of the document describes what is it, but also what is it supposed to do. So when we're talking about network-based security, this concept of a least privileged description of behaviour is like a cornerstone foundation. This is giving you the envelope. So later on, I think I'll actually show you one. Specifically, an ANAM as an echo will communicate with certain IP addresses, certain domain names on the internet over certain ports. If it starts doing something different, one or two things has happened. Either the rules have changed, or that device has been corrupted. So this concept of a least privileged description of behaviour, which can be tied to a device type, is a very worthwhile initiative, and certainly we embrace it. There are some issues with it, I'll touch on in a minute, hopefully D3 solve. Matter, I dare say, some of you may be familiar with. So this is the big Zigbee derivative, or the follow-on from Zigbee, which is providing the application layer protocols that mean when I buy my temperature humidity sensor, it's going to work with my Echo, my SmartThings, and my Apple Kit type stuff. So it's I don't think the specs are in the public domain yet. I mean, we are members, so I've seen the content of it. Some good stuff in there. Certainly it's got some of those low-level primitives in terms of sort of like certificate-backed security, which lays good foundations. But however big this is, or however universal it is, it's still got a lot of ground to catch up on. It's not going to happen overnight, and it definitely won't be the only play down, because every action creates an equal and opposite action in the commercial sphere. FIDO Alliance, so don't take much attention to the text, I'm going to probably flesh it out. Just look at the logos. So FIDO Alliance, that you may or may not know, is used for sort of like multifactor authentication. They've also got a specification on IoT provisioning. There's some interesting overlaps with sort of some parts of Matter, in that it's another certificate-backed sort of technology. It's got some sort of like device attestation, so methods by which you can see is this device with a device. But also it's got concepts of ownership transfer in terms of I buy a device and can I pass it to you and pass it to someone else. So again, this exists. There's a full spec there. I don't know what the adoption is going to be like yet. It's the spec's been there for a bit, but I haven't seen the structure.
I think it's fair to say that it's basically Intel's whitewashing of their SDO stuff, and so it's out there without actually having that logo on it.
Yeah, no, agreed. Yeah, and I think that comes quite transparently if you look at the technical details. Software bill of materials. Anyone familiar with SBoM? Yeah. So this looks like it's going to be a big deal. It's being pushed from an executive order from the US. Its intent is good. Basically, the idea is every device creates a manifest of what it's built from. And that manifest can be made up of essentially hashes, so you know where it comes from. And fundamentally, it's a way of you establishing the potential vulnerabilities based upon the component description of the object. So it makes total sense. It's a worthy initiative. There's a couple of competing physical specs. I mean, I think the executive order's been listed as a set of requirements, and then there's SPDX and CytoDX as two competing specs. attempt to do the same thing. Technically, I can see lots of problems with the rollout, and having spoken to some of the authors of the technical specifications, it might be an example of the political appetite running ahead of the technical ability for it to be made real. However, it's definitely something worth keeping aware of, and certainly some of the things that we're trying to do in D3, you can see as almost like a micro subset of what we're doing in software materials.
Nick, what's it next?
What's the what? I've got a slide on that in a bit.
Okay.
I only learned what a VEX was last week from Elliot. So I'll explain what it is. So the idea is, I mean, vulnerability databases, I dare say most people are familiar with vulnerability databases. There's several of them, some of them are the national. But the idea is the vulnerability database is, it gives you something to look up to see what the potential risk is. Now, what's interesting is when you put them together, well, this is the intent. So this is what they're hoping to achieve. So this is Elliot's slide. So this is what they're hoping to achieve with SBoM. So SBoM is a description of the software that's in the device. That software is made of components. And then the vulnerabilities are registered against each component. Now, that then gives you like a set of sets, right? This has got God knows how many components in it. I don't know, 100,000? Well, actually, this is numbers and millions. But even a very, very small device will have lots of software components. Each of those would have lots of vulnerabilities. What happens when you try and achieve this ambition without a containment? You have so many false positives, right? Because there are so many vulnerabilities that out there. What the VEX is it's a vulnerability exchange.
Exclusion.
I think the acronym is a vulnerability exchange, but it's used to exclude. So basically, you've got that temperature humidity, there's 25 components, each 25 components got 100 vulnerabilities, that's 2,500, that's useless. So the idea is then the vendor then produces a list of almost like exceptions. I know this is registered off the database, but we've fixed it because of that. Yes, and we fixed it because of that. This is part of the reason our next one work. It's complicated, but the intent is good, and the ambition is good, and we'll see how that maps to other stuff in a minute. Yeah, so the VEX is the list of customer repair. And then another one, sort of MISP, that's another. Steve has talked about this. So that's sort of threats in a sort of different dimension. Sort of like vulnerabilities are this sort of software component, this thing is risky. The MISP database is more, actually, these servers are risky, generally. And therefore, if something is talking to one of these, you can infer something funny is going on. So, I'll just quickly introduce those as concepts. Some of you may be aware of, some not. But they're necessary to understand how some of the more advanced D3 scenarios are built up. So, well, how does it work then? So I showed you a version of this slide before. You've got the monitoring, you've got the responding, you've got the smarts, and then you've got the coordination, right? So the coordination is how do we share and communicate and talk about threats. Now, in everything that we are developing in D3, we're building it on verifiable credentials. So verifiable credentials are emergent. I think the first version has been released. W3C spec. They're sort of glorified certificates with JSON payload and a slightly different sort of semantics in terms of who the signatory is. We feel they're ideal for doing the type of thing that you want to do. They're very flexible. The semantics of what you're trying to express in there are transparent, and it doesn't cement in like a fixed CA chain. Right? It allows for a lot more dynamic ability to express things, but then a lot more dynamic and distributed, that's what the D is for, ability to validate things. And fundamentally, it's great for sharing. It's great for disclosure, it's great for encryption, and it's great for validating the provenance of a statement that is being made to you. And that's fundamentally a lot of what we're doing in D3, is an expression is being made, a statement is being made, and we want to validate, well, who's it coming from and do we trust them? And then we can assemble it from there. Fundamentally, yeah, it looks very much like a certificate. Each distributed device descriptor, it's got a subject, what is the thing you're talking about? It's got a type, what is it you're trying to say? And then it's got the payload, which is just a massive lump of JSON, which can express pretty much anything that you want. There's a few other sort of standardized attributes in there, but that's fundamentally the core of what we're using it for. But then the key thing is that whole package is then signed, and then the signatures can also be nested for more complex expressions. And fundamentally, we're using these because it's very, very good for making distributed statements. Especially on sort of like peer-to-peer connections, which is a lot of the IoT scenarios. And in the way that we're using it, the issuer, I'll dig into it later, can be lots of different types of things. People can issue statements, organisations can issue statements, devices can issue statements, routers can issue statements, cloud-based services can issue statements. Because all of those different stakeholders know different things about the system, and then using this sort of method we can sort of like build up. Right, so that's foundations. Right, now specifics. D3 events, right, formerly called NetMon. It's actually really simple, right? It's a glorified wrapper around sort of like network capture. Actually, on an implementation level, we put out PCAP files and we process them. So what is it? A D3 event it's a stream of stamped security relevant activity. It's a log file basically. It's a glorified log file. The difference is, because we've wrapped the conceptual signatories around it, we can assemble log files from different entities on the network and assemble it into a more comprehensive solution. Technically, it's a gRPC API. So gRPC, people don't know that's Google Remote Procedure Tool. Forget about the G. It's just really efficient. So it's binary on the wire. It's based on HTTP2, so it's quite efficient from a networking perspective. Much better than doing REST type stuff. Some of the questions we might ask is how we might enhance those APIs going forward. But we found gRPC to be perfectly fit for purpose for what we're trying to do to it. And conceptually, most, but not necessarily all going forward, but most of the D3 events we're issuing at the moment are being issued by the gateway itself. Because the gateway is doing the capture and then it's just upstreaming the event. Now, the point is, the payload is then defined in a protobuf message, so that's sort of like a spec layer underneath gRPC. It's just a binary representation of data. And the biggest challenge we've got in defining the D3 events is getting that balance between expressiveness and efficiency. Because there must be enough information there must be expressive enough, such that when we want to apply smarter analytical techniques, we can pick up security pertinent events. But we can't go around chucking all the network activity to the cloud or communicating, otherwise every piece of network traffic doubles. So it has to be, and that's one of the sort of like challenges where dynamically sort of like addressing the project and working what that right level of representation is. DCon is the inverse. So
you can talk about where trust comes into.
I will. Yeah. I mean,
one thing I said is that you said they're conceptually signed by the gateway. There's a whole trust thing around it. Why do I trust you then?
Well, okay. Well, just I'll so that this is sort of what D3 is attempting to solve in the widest and most ambitious form, right? In the way it's actually being done now, you'll attach to the stream by an authentication authorization method as yet undefined. On our implementation, we have a method, but that's not necessarily saying everyone needs to use that. But ask yourself the question: if there's a router there and it's issuing a set of events, why should I trust it? Now, there's a chain. I could express it as a chain, which I could say, well, what silicon is it running on? It has the big one being signed by a private key with the secondary bootloader. The secondary bootloader then needs to express what may express the manifest of what hardware it's running on, because obviously there's more than primary CPU, as well as the software bill of materials, which is where the next bit fits on, and then you chain all the way up. And actually, if I really truly want to trust, I need to be able to test to that full chain. That's more ambitious than we're targeting at the moment, but we've got the primitives to be able to express each step in that chain.
But that's really only trusting the router. So the router, if the router thinks it's observed an event and has truthfully reported it, that will satisfy all that. But if there's some malicious thing attached itself to the network and starts sending out...
Oh, that's the secondary reasoning on top, absolutely. Yeah, absolutely. And well, to some extent, that's the real problem we're trying to address. Just as an aside, I was saying, but I think some of the primitives of building up D3 can partly solve that underlying problem as well. I mean, the reality of any real system, there is implicit trust all the time. All we're trying to do is raise the bar of how explicit it is and what so DCon's the inverse. So it's designed to be distributed control of networks. So in that complex heterogeneous scenario that I put up right at the start, it's not a question of just, in theory, controlling the primary router. You might have the primary router, two extenders, a LoRa gateway, and an NB-IoT, blah, 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 blah. So the API is designed to be able to aggregate that capability over a single supply control point. Again, it's expressed primarily as a gRPC API because it's fast, efficient, and secure. And fundamentally, it's really, really simple. What's inside it at the moment is really simple. It's disable the device. Now, the interesting question is what is a device? Which I'll touch on in a minute because that's a non-trivial problem. Constrain the device, which is this device I expect only to do this, so I as a router will be responsible for enforcing that. And then segment network, which is actually a coarse-grained level of constraining device. So basically what you're saying is, okay, microscopically restricting each device to only do this is actually quite hard, both computationally and logically. If I create three major segments that have slightly different visibility, then I can do that. So in a lot of what we're building with D3, we're not saying it must be done a specific way. We're providing the tools via which different policies and different systems and different authorization and trust chains can actually be built. I'm not going to pull up the gRPC APIs this afternoon. If you want to go through that, we're happy. We'll sit and go through the actual specs. But some of the big questions that we're sort of like thinking behind, we have something that works now. It's demonstrably working. We can show you working. But if we want broader industry adoption, do we need to augment the gRPC with the best API? Do we want to implement some sort of like a bearer agnostic API, which essentially allows you to send commands where the trust is not implicit in the authentication of the connection? That's actually what a D3 does, because the D3 wraps the authentication around the command. How do we authorize those remote connections? That's a whole world of interesting questions. On an internal network, how does one gateway trust another? And then actually the most important near-term question that we need to really resolve, and we're actively asking for, I think one is, okay, what do the D3 event profiles look like? So we have a whole host of D3 events we're proposing in terms of which attributes from a TCP packet we upsell, which packets from a DNS packet. But we need to work out what's the right subset that sits on that right efficiency, expressiveness continuum. So those are like the underlying. Now, this is where it starts to get a bit more interesting on the actual D3. How the thing works together. So on the left, on the left-hand side, you've got the D3 events. So this is your stream of network log, essentially, right? And that's going into a local store because we want to remember it. Because if we want to do any statistical inferencing or reasoning or AI or ML or your networks, we need a historical store stuff to think about. Then we've got this thing we call D3 types, which I'm going to sort of like dig into in a minute. So the D3 types are essentially a high order expression of typed devices which we can infer exist from the traffic that we see. So go back to my Amazon Echo example. I see traffic on the network because the route I just see MAC addresses and IP addresses, and I see sort of attributes on traffic. What is it? How do I know what it is? And how do I express that type? And that's what the D3 types essentially do. They enable us to define a taxonomy, a hierarchy of types, and they enable us to plug in expected behaviours to those types. Now, those types come from an external authority. Now, I'll come back a little bit later and work out what that external authority is, but actually the mechanism by which that is synchronised, the external authority with the local router, is, at the moment we're just using a git claim, because it's simple and efficient, it works, and it doesn't synchronize anything for you. But then the interesting thing is the inferences, right? So what I'm seeing in the D3 events are just absolute facts. The D3 types give me sort of like a language to express higher order concepts in the system. But fundamentally, most of what we're doing in the system is drawing inferences from what I see. And this is where the whole cognitive metaphor comes in. And generally, we divide the D3 statements into two types: assertions and inferences. So assertions mean here is a fact that's coming from an external thing, right? So a fact, and therefore, how do I know that thing is true? Well, what I do is I look at how it's been packaged as a D3 statement and look who signed it, and then I make my judgment as to whether I trust that, depending upon whether I trust the issue or the signature. An inference is a new statement that's made, but it is a logical corollary of the underlying information that I've seen. I'll give you some very, very simple, concrete examples of this in a moment. But yeah, and in inferences, we've broadly got to, I mean, Steve might talk, there's actually three, but I mean, I'm going to talk about two at the moment. There's a deduction and induction. So in mathematical, logical terms, a deduction, right, is something that is absolutely true because of the statement. You know, all crocodiles are green. This is a crocodile, therefore it's green, kind of thing. It's an absolute logical set of statements from which you can draw inferences. Induction is a softer. Induction is I'm not drawing inferences from a set of facts from authority. I'm drawing inferences based upon some form of statistical regularity. So most inductive reasoning methods are generally they're Bayesian in nature or similar, and you've got some statistical threshold at which you believe this thing must be true. It's the classic, I don't know, the white swan thing. You know, are all swans white? Well, yeah, because every swan that I have seen is white until I see a black swan. That's the origin of the black swan thing. But that's also all of the inferences that we see in the system are divided into these two types. So, how much is time? Yeah, I'll just about get there. First problem, perceiving an instance. It's a remarkably difficult problem, actually. From the router, how do I know this device is the same device I saw yesterday? Now, actually, it's really hard for this device because as of, I don't know, about a year or so ago, all Androids and iPhones rotate their MAC address every day. So, interestingly, most IoT devices don't rotate their MAC address every day. But the point is, if I want to reason about a thing on the network, I need some stability, which is probably better than just a MAC address. A MAC address, we can reason off the MAC address, but then we have to discount that. Well, in that it can easily be spoofed, there can be duplicates, blah, 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 blah. And also I know it can be rotated. So the first level of the D3 event is basically when or the crude one, when I see a MAC address that I've not seen before, I create a unique identity. I create a new identity on the router, and then I use that as my handle for talking about that device in the future. So I'm not dependent on the IP address, which will get rotated, and I'm not dependent on the MAC address, which will get changed. There are other methods by which we can infer an instance, and if it has a master certificate or a FIDO certificate, or even if it's got a HTTPS certificate, that's got a bit more sort of stability to it. But the first layer in the whole system is just saying, is this a device, and how can I talk about this device? Because later on, I might want to disable it, and I need a handle to be able to disable it, because it could, try and hide from me. Next level is observing instance behaviour, right? And actually, this is quite simple. So the way that it actually works on the systems that you'll see later is the router observes the raw PCAP information, That PCAP information is then distilled into a finite set of events. And then those events are then just collapsed into unique instances. So let's use the Amazon Echo example. The Amazon Echo might call home 125 times a day, right? So in the D3 events, I'm going to see those 125 events. But when I collapse it down to the rule, all I would need to know for these privileges, this type of device talks to that IP point on that port number or this port number range. And then we can create a claim, like an ephemeral claim, which is, this is the collapsed set of rules that relates to the what I've seen observed on this instance, this thing. Now, I'm constantly using the word instance here because the crux of this is actually the tying between an instance and a type. And I don't know if this is going to help or not, but it's just mushrooms. So why mushrooms? Right? Some mushrooms are dangerous and poison you, some mushrooms aren't. As I walk through the forest, what do I see? I just see shades of grey and green and blue and brown. Right? Now, for me to determine the riskiness, right, I have to do a lot of processing. I have to work out, well, these are fungi, and then when these are fungi, I've got to think, what class of fungus does this relate to? How confident am I in that? And then based upon that, I can make my risk assessment. That's my analogy for explaining exactly what we're trying to do when we're trying to establish the riskiness of the device on the network. And going back to use the other metaphor, which is a little bit riding, but one is, underneath that, I've also got to make sure, well, this fungus might be pretending to be another fungus. So these are the two sort of like dynamics, the underlying problems we're going to solve is, how do we express the type, and then how confident are we that this instance of the device is the type? And this is the core. The core of what we're developing is the main assertion in the DCon is the assertion of a type, and it's really simple. Right? It's a unique identity. We're using GUIDs for the moment, but we can use Earl aliases, a manufacturer name, model number, and a couple of URIs that you might want to use that are human readable. There's no meat in it. It's just I'm abstractly saying this thing exists. And once I assert this thing exists, I can then start tying information to it reliably. So this type of device might accept a whole chain of different firmwares. That's something interesting that I can describe about the device. And interesting actually when you do tie a firmware to a device, you can possibly change the behaviour. The main thing I want to do is express its behaviour, its expected behaviour. My brother printer that's sat at home in my office, and the other one that's in my work office, two different brother printers, they're two different types. They have two separate different types of behaviour. And so what I can do with these D3 claims is just make these simple statements and then upload them somewhere that they get the reason on. But there's a couple of underlying things about this. This is designed to work with legacy devices, and it's also designed to work in the case that you don't trust the manufacturer. Because some of what I just described you can do with mud. But what you can't do very easily is do the legacy stuff. There's also some subtle problems with mud in terms of actually it's not actually secure in terms of the documents it sends. And so these are the problems that it fixes. The other thing that it fixes, and we'll touch on this a bit later, is going back to the vulnerability thing. It's sort of doing something quite similar to the SBoM thing, that I have this device, this particular webcam from this particular vendor, with this particular firmware. I know, because someone has told me, that it's got these 3-4 vulnerabilities. Basically what D3 types are doing is they're giving you a unique key to be able to merge all these different information systems. In the database construct, with basically primary keys and foreign keys, and we actually manifest them like that. So this then starts to dig into the trick, the interesting thing about it, right? So the nexus, the hinge on which this whole thing talks around, is this assignment of a type to an instance, right? And there are systems that exist, like Matter, like FIDO, like MUD, that do this in a very static way, right? But they assume their statements are always true. What we do in D3 is provide a very flexible way of being able to do this. And this is a multi-factor validation of the same thing. This is going back to the little bit winding code thing. So what I've just given you here is an example of all the different possible ways that the gateway might come to some sort of assumption that this particular instance of a device is of this type. So first thing I can do MAC address recognition. I can do that, it's fine, lots of systems do that. I mean, it's not very secure, but it's evidence, it's weak evidence, right? It's weak evidence that this particular device is from Amazon or Huawei or Cisco or whatever. But anyway, that's one layer. Another layer is really, really simple, user entry. Right? Now, whether it's an administrator or a user, I could just type it in. So when I onboard the device, I could just type in the model number. That provides me another level. You've got the hard methods, matter certificates and FIDO certificates. So these have a very well-defined set of semantics defined in their ecosystem and a set of attributes within their certificates that will do this. Fantastic. And if it's there, great. But if it's not, I still need it to work. And this is why D3 is the way it is to handle the legacy situation. But also, there are going to be situations, I mean, if you have compromised a device, you can compromise the certificate that it's expressing. QR code is a glorified way of doing the user entry. A MUD document or MUD URL also gives you a way of ascertaining device type. The problem with MUD, for those that are interested, is the three ways of expressing the MUD document, the most normal of which is embedding the reference in a DHCP request. The point is that can easily be switched. So this again, this foundational thing again. Yes, I can see something. Yes, I can pick it up. Yes, I might trust the integrity of the person making the assertion, but because the underlying protocol can be corrupted, I have to discount that. And then you can start getting the more sexy stuff, like port scans or behaviour monitoring. You can even build up a whole ecosystem where actually issues types with sale vouchers. And I think this is a bit of the segue into what Steve's going to be talking about, partly anyway, is then there's just the general external logic. So the whole point about the D3 type instance recognition statement, which is 3 parameters of information, it is implementation independent. Right? I can accept one of these D3 statements from any of these sources and assimilate them and reason them and then come to my own determination of trust based upon all the information that's incoming. But if on the external logic side of things, so what does that mean? Well, if I have access to the underlying data, I could do some sort of funky Bayesian inferencing, and there are products on the market, proprietary products that do that. I could do some decision tree stuff, which John's quite familiar with, to do the same kind of thing. I could create some funky neural network that uses a transformer architecture, but I'll need shitloads of data if that's going to work, and that's why we need the D3 event stuff to make it work. The point is, what we're developing in the D3 statements is the ability to consolidate all of this information, both from what a user says, what exists in the certificate, and some really advanced sort of AI techniques. But it's establishing a security interoperability layer.
Is it always an instance is one, or is it an instance? It's got a probability that it's this type, a probability that it's that type.
Well, yes, no. So you've got to break it down. A D3 statement is issued by a thing, right? So that's I haven't got the slides on this, but basically, when you as the receiver of a piece of information, this is the subjectivity thing. I might get a claim from 4 different suppliers saying different things. Within the claim itself, so when I determine the truth of the statements, I mean, we don't impose this on the system because it gives flexibility for different reasoning systems, but one obvious way of doing it is you, as the claimer, can make your statement of how confident you are in that. Right? 70%, 20%, I'm always right 100%. When you send it over to me, it's signed by you, then I can discount that by how much do I trust the method by which you sent that to me, versus how much do I trust your confidence in your ability to assess your confidence. And then you've got the collapsing function, which is to tell someone else, John's given me another piece of information, and so who do I trust more?
So you have multiple type claims, and you've got at any one point in time a kind of view of your summary of those. And that could change based on your confidence in one of those sources change.
I mean, in the most simple example, you wouldn't go to that level. But to be honest, I'm not saying to you anything that isn't common sense. This is just the world. This is just the reality. If the certificate, a classic web-based certificate, has been issued to me by a CA, and we know that CA has been compromised, I have to discount that claim via different methods. All this is really doing is giving us a more unified way of expressing that confidence dependency, and also being explicit about the subjectivity side of things. So going back to what I said earlier, trust is not binary. What we're trying to do is get away from the model. Well, not get away from the model. Build on a model where trust is always just implicit on your belief that the CA is always true. It's much more complicated.
So can I ask you, in terms of establishing that trust, you talked about trustworthiness, so presumably you set a level of actually you pass the threshold of being sufficient trust.
Yeah. And going back to what I said before as well, yes, but to do what?
Well, the question is that, how do you determine the trustworthiness level?
Well, that's up to you. Like a hospital has a whole, most people in the IT know there's like a whole different set of sort of like frameworks and trust foundations. So what this just is, that allows you to express it. It allows you to express both the evidence, but also to express your policy in terms of your confidence. So yeah, absolutely, that's exactly what's supposed to do.
And so, can I ask, would we expect a predetermined set of those trustworthiness levels?
I'm not going to say anything about that, but I mean, you as ITSF might decide you're not going to do that. No, but that's exactly the case, because I mean, it's like,
well, an instance would be turn on the light switch, shut down the nuclear reactor. There's obviously two different policy levels. Who determines those? That's a good question. And that's where guidelines probably comes in. Could well be in our demand.
And okay. I'm going to do one more slide, then I'm going to hand over to Steve.
Sorry, can I ask, just a bit confusing about this instance versus device.
Yeah.
Instance, how the different, you said when you're trying to profile or identify a specific device on the network, then you use the term instance. Is that what is happening?
So with most sort of like logical systems, there's an instance of the thing and there's a type of the thing.
Okay.
Right? So the point is, when I'm on the router, all I just see is the ephemeral data that relates to the instance of the thing.
Instance meaning the device that is
that physical device. This specific model of Galaxy Ultra 22 with this particular firmware. That's the. So it's this one, but there's a whole. There's a million of these in the market, right? But they should all have similar behaviours. And so when I'm describing the behaviour, I want to describe the behaviour to the type, not the instance. And so a lot of the reasoning that's going on is on this fulcrum of how confident am I that this instance is of this type. And I think this is the slide I'll finish on before I hand over to Steve, is fundamentally the most basic use case that we've got, this might work this afternoon, we'll see, is, so here's the thing. We see what that thing is doing. We see, like, day by day, second by second, what that thing is doing. We can collapse that into a set of rules, right? Which is then, this is what I've seen generally this thing to be doing over the last month, year, day, whatever. But then I've got an abstract description of the type. Let's say again, it's my Amazon Echo, right? And I have a description, a least privilege, authorized description of what it should be doing. So really all of it, once I do this thing here, which bridges into this instance of this thing, then I can spot that anomaly. That's fundamentally, when you break it down into its most simple sense, that is what it is. So if the observed set of rules is greater than the defined set of rules, we have a problem. Now, what do you do in that case? Then blah, 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 you might find actually your set of rules are rubbish, or you might just find, this is just like a firmware update that only happens once every 2 years or whatever. But this, in the most simplest sense, that is the most basic activity we're going to do, and these things coming together.
So the categorization of type just has to be general enough to get to a set of defined behaviour that you want to measure against.
Exactly.
So it could be all Amazon echoes rather than an Amazon echo V2, V3 or whatever.
Exactly. So
Okay.
what I'm going to do is I want to hand over to Steve for lunch. He's going to. Have I done enough to get the foundations of what you need? Okay. There's some much more complicated questions to do with about how do we come to this type hierarchy and what are the authorizing. I'll do that stuff after lunch. Yeah. So I put it on.